Hello, everyone. My name is Luis Carlos Gonzalez. I never thought how difficult it would be to record a 5 minute talk. I have been investing like 2 or 3 hours doing this. I hope this makes the final cut. So I'm going to present Inferring aggressive driving behavior from smartphone data. Authors of this study also includes Narvaez, who is the leading author and currently is the PhD student in the computer science program in the Universidad Autónoma de Chihuahua, and also Johan Wallström, who is a colleague working in UK. So when we pay attention to different numbers reported by the World Health Organization, we found that about 1.3 million people have died in road accidents. If we use a focus on traffic crashes with injuries in these people, this range go from 20 to 50 million people. More than half of these fatal accidents are caused, according to the AAA Foundation, by aggressive driving behavior. So one of the goals of this project is to exploit driving data collected by the driver's smartphone. So analyze this data, the sensor data that is being collected by machine learning algorithms, and infer what caused this signal. Then give proper feedback to the driver, where mainly focus on risky maneuvers like speeding, aggressive lane changing, sudden braking, aggressive turn. All of this is possible because the smartphone comes integrated with different sensors. These sensors have the ability to measure deviations, velocities, accelerations in some axes. So at the end, we can sense what the vehicle is experiencing. Many times, there are situations that make this problem difficult. So, for example, the signal-to-noise ratio, given that the smartphone was not originally designed to act as a sensor, is commonly low. So we need to filter the noise in order to get a meaningful pattern in the signal. And another situation that occurs very frequently is that as many sensors that you integrated into the solution, you need to find a way to discriminate what information is useful from the sensors and what other information is just noise. So at the end, we have two very hard problems that we need to tackle. Different risky maneuvers have different signatures in the signals. So the algorithm or the machine learning algorithms need to be able to discriminate and find patterns, shapes, signatures, microsignatures in order to classify these events. What we're doing to tackle this problem is that we want, for filtering purposes, we're applying like a gated mechanism. A gated mechanism is a model based on different gates. For example, here I am just presenting like three gates with that are shown in a green square. And this model learns what information to flow in and what information to block. And at the end, you will have a cleaner source or data source that would be very helpful to discriminate or to identify a certain maneuver. And also we want to exploit the nature of the sensor's data that most of the times come as a time series. So we want to apply a specific time series classification algorithm to exploit all this structure. At the end, we're designing and evaluating different models that integrate these two original ideas into in each one of these models. So we have these different inception layers that are the mechanisms that act to extractors from time series data, and also the gated mechanism that learns what information to let go to the next level. And at the end, we want to improve the classification. How the gated mechanism work? For example, here in one data set, we are showing for two sensors, and we have in the x-axis like different maneuvers. We can see that there are different amounts of information that are being learned by the gated mechanism. So it is important to know that we don't have a specific threshold, but we need to learn what amount of information is useful to identify one of these maneuvers. Also, in a different data set, we are showing how the different models are being used to successfully classify, and many of our models are just reporting like a very high classification scores, even outperforming the original Inception time, that is the state-of-the-art mechanism that is based or that is being used in this project. So these are the results of our study. I hope you have enjoyed this small presentation. And if you have any further question, just please just make it clear. Thank you.